Hello and welcome back to another video series. In this video, we will define what is a diode. We look at its symbol, the component, and how they construct a diode. Firstly, let's define what is a diode. A diode is a two-terminal electronic component that conducts current in only one direction while it blocks the flow of current in the opposite direction. So the symbol of a diode is given where it has the anode and the cathode, and the physical component can be seen with the figure given. So in that case, we can identify that the diode is mostly connected in a forward bias region, and also it blocks the current to flow in the opposite direction. In that case, we can see that there are two operating modes of the diode. One is called the forward bias mode, and two is the reverse bias mode. So for the forward bias mode, that means it is a conduction mode, and in the definition it is given as having less resistance, while for the reverse bias it has high resistance. So when it has high resistance in the reverse bias mode, that means it will disallow the flow of current. Why do we need to conduct the flow of current in a specific direction? Imagine you have a multiple voltage source and multiple current source. So there is a circuit in which you want the flow of current to a specific area or a specific component within the circuit. That's where you need to use the diode. So in that case, you will allow current to flow through this particular region or the component using the forward bias mode, and you can block the current to this particular component by using the reverse bias mode. So in the forward bias mode, it is connected in a circuit such that if you have a voltage source and you have the diode connection in this way, we say it is the forward bias mode, because with the arrow which is pointing in this direction, by applying the positive terminal of the voltage source to the anode, you will now allow the current to pass through. On the other hand, if you apply the negative terminal of the voltage source to the anode and the positive terminal to the cathode, now it is in the reverse bias mode, because there won't be flow of current in this direction. It will now blocks the current. So later, if we look at the construction, we will explain what really happened inside the diode that disallow the current to flow in this direction, while what happened inside the diode which allow the current to flow in this direction. Inside a circuit board, you will also realize that there are components like the generic diode, which is given with this symbol, a Zener diode, a Schottky diode, light emitting diode, tunnel diode, and photodiode. All of these plays an important role in an electric circuit. Why do they all have the same name diode? Well, they have the same name diode because they all operate using the two modes. They allow current to flow in one direction and disallow the flow of current in another direction. So for example, if you want to control this light emitting diode, you have to connect the positive or the anode of the LED to the positive terminal of the battery, and negative to the negative terminal of the battery, or the cathode to the negative terminal. Now you will allow the LED to light up. If you change the polarity, then it won't allow the LED to light up. So the similar apply to all other diodes. Let us now look at how the diode is constructed. So the diode is constructed such a way that it is composed of the p-type semiconductor material and the n-type semiconductor material, and in between is known as the depletion region. So the depletion region is responsible for having the term resistance. Let us now look at how the p-type and the n-type semiconductor material were created. So p-type and n-type semiconductor material, the term semiconductor material are mostly the silicon and the germanium. They can be found in the group 4 element of the periodic table because they have 4 valence electrons in the outermost shell. So in order to create the p-type semiconductor material, the silicon or germanium of the group 4 must bond with the element in the group 3. Group 3 element have 3 the group 3 in the periodic table, they have only 3 valence electrons. So in that case, when these 3 bond with the 4 electron in the outermost shell, to make it become stable, there will be 1 holes remaining. So imagine when we have more and more of this atom connected to group 4, group 3 to group 4, it will leave more and more electrons. So in that case, it is from the p-type semiconductor material. So we can see that the majority charge carriers in the p-type semiconductor materials are known as the holes, because this hole is formed by bonding group 4 element of the periodic table with element group 3 in the periodic table. So what will happen in the n-type material? So we bond the group 4 with the group 5 element. So most of this process is known as the doping. So we have group 5 bond or dope with group 4. That means 4 of these electrons in the group 5 element will bond easily to group 4, creating a stable atom, while 1 electron will be loosely bound. So when more and more of these electrons are loosely bound due to more and more atom of group 5 element and group 4 element bond together, they leaving more and more electrons, which is known as the majority charge carriers. So this is mostly with the n-type. So we can summarize that when bonding group 4 with group 3, we create p-type, and bonding group 4 with group 5, we create the n-type. So this is the process known as the doping. And because most of the case in terms of the conduction mode and non-conduction mode is mostly based on these charge carriers. So we can say in the n-type region, we have the majority charge carriers, which is the electrons, and the minority charge carriers are the holes in the n-type semiconductor material. And in the p-type semiconductor material, we can easily identify that there are more and more holes, which is the majority charge carriers, and there will be electrons, which is the minority charge carriers in the p-type semiconductor material. And this is the basic chemistry behind the construction of a diode. Let us now look at the example if we connect the positive terminal of the voltage source to the p-type and negative terminal to the n-type semiconductor material. What will happen? There will be more and more holes flowing in this direction, and they will accumulate at the p-type region, and in this direction there will be more and more electrons flow, and they will accumulate in this region. So in order to perform the force of attraction, we know that the positive and the negative, they tend to have a force of attraction. In order to achieve this force of attraction for a silicon diode, you have to have a voltage greater or equal to 0.7 volts, and for the germanium diode 0.3 volts or greater, in order to have this force of attraction greater. So what will happen is that when we apply voltage greater than the voltage given here, for example, if it is a silicon diode, we apply more than 0.7 volts, that means this depletion region will shrink. So what will happen is that there will be more electrons in the n-type, which will have greater force, which will now attract all the holes in the depletion region to bond with all these electrons. And similarly, in the p-type, there will be more and more holes which will have greater force, and it will now attract all the electrons in the depletion region. So that is why they say the depletion region will shrink and having less resistance. So due to the interaction between the electrons flowing in this direction and holes flowing in this direction, we know that there is a flow of current. When there is a flow of current, we know that the diode is now in the forward bias mode, which means it is having less resistance, so the current can now easily pass through. So in that case, you can see that it is mostly with the interaction between the holes and the electrons in the n-type and p-type with the depletion region. So without the movement of the holes and electrons in the depletion region, then this barrier will have high resistance, which will not facilitate any flow of the current. And what will happen if we connect positive in this region and negative to the p-type semiconductor material? We now know that there will be more and more holes in this region flowing in this direction, and in this direction there will be a lot of electrons in this region. So for the n-type, since it has more free loosely bond electrons, all these electrons now will move in this direction to bond with all the holes. Similarly, in the p-type, there will now be the flow of holes in this direction to bond with the electrons in this direction. So we can see that there is no movement of electrons between the depletion region. So the depletion region does not change because all the electrons are attracted to the positive terminal and all the holes are attracted to the negative terminal. So in that case, we say no conduction, because there is nothing happening between the electrons and the holes within the depletion region. So they regard it as having high resistance, when high resistance simply mean no current flow. So this will result in the diode being in the reverse bias mode. So this is very important scenario in which one can identify the chemistry and the happenings in the p-type and n-type semiconductor material of a diode. I hope this explanation is very simplified for you to understand what is happening in a diode. So diode is an important component in an electric circuit. So the principle can similarly apply to a component known as a transistor or the MOSFET. In our later video, we'll look at what is a transistor and what is a MOSFET, because the transistor and MOSFET, they now have the ability to build the digital circuit. The digital circuit is mostly made up of the logic gate. So the logic gates are built from a transistor and the MOSFET. So if you can simply understand fully what is a diode, it is very easy for you to understand what is a transistor, and finally you can easily identify the digital logic circuit, because the diode is like a principle in which all the circuits are derived from having the main idea of controlling the flow of current. Therefore, thank you for watching our videos. If you like our video, you can kindly like and subscribe to our channel for more greater video like this.